Let us consider this example. So we need to determine the output voltage for the given circuit. So they have given the circuit. So as you can see, it's a half-wave rectifier circuit. So let me to analyze this one. See, I'm going to consider this ideal diode. So input waveform is given with the amplitude of 10 volts. So during positive half cycle, so this is the positive polarity and negative polarity. So the diode will be in the on condition, that is it will act as a closed switch. Because of this one we are going to have a current in the circuit I. So this is the output voltage V0. So I'm going to apply KVL for this circuit. So if you apply KVL for this, as we have considered diode as an ideal diode, so diode is replaced by a switch. So Vi minus V0 is equal to 0. That implies V0 is equal to Vi. Output voltage will be equal to input voltage. So during the negative half cycle, the polarity will be like this, negative and positive. So during the negative half cycle, diode will be in the reverse bias condition. That means it will act as a open switch. The current in the circuit will be equal to 0. So therefore during the negative half cycle, V0 will be equal to 0 volts. So I'm going to draw the waveform for this. This is input voltage Vi. From time duration 0 to t by 2, that is the positive half cycle. So we are going to have output voltage is equal to input voltage. So this is V0 and the amplitude of the V0 will be equal to 10 volts. So during negative half cycle, that is from t by 2 to t, so diode will be in the off condition. So output voltage will be equal to 0. This is the waveform of output voltage with respect to the given input signal. So by considering diode as a ideal diode, so let me to take it as a practical one, and I'm going to solve the problem again by considering D as a practical one. To solve this one, we have to consider the barrier potential of the diode. So for that I'm going to consider the barrier potential for silicon as 0.7 volts. This is the barrier potential. So during positive half cycle, so diode is in the forward bias condition. The circuit will be like this. So we need to replace the diode with the barrier potential. This is V0 output voltage and this one is Vi and this is 0.7 volts. So during positive, so diode is in the on condition, the current will flow in this circuit. In order to obtain the wave equation for the output voltage, we are going to apply KVL for the circuit. So for this, plus Vi minus 0.7 volts minus V0 is equal to 0. That is V0 is equal to Vi minus 0.7 volts. So this is the expression for the V0 during positive half cycle. Same thing. So if we consider the negative half cycle, the diode will be in the reverse bias condition. It will act as a open switch. So therefore there is no current flowing through the circuit. The output voltage V0 will be equal to 0 volts. Let me to draw the waveform for this. You need to be careful while drawing the waveform. So this is the input waveform. We are having a amplitude of 10 volts. As we are considered diode as a practical one, we need to consider the barrier potential. So here we are having a barrier potential, that is the positive value. So I'm going to represent that in this waveform. This is the barrier potential, 0.7 volts. So I'm going to draw the line parallel to this. The output voltage V0 is equal to the maximum amplitude we are having for the input is 10 volts minus of 0.7 as equal to 9.3 volts. As you can see, the diode will be in the reverse bias condition until input voltage increases to 0.7 volts. That means when the input voltage Vi is less than 0.7 volts, the diode will be in the off condition. Therefore, V0 is equal to 0 volts. That means until this point of the input waveform, that means this is the 0.7 volts, until that the input voltage is less than 0.7 volts, the diode will be in the off condition. Therefore, the output voltage will be equal to 0. When the input voltage increases from 0.7 volts, the output voltage will be equal to Vi minus of 0.7 volts. Therefore, the waveform will be like this. The maximum value we are going to get for the output voltage is equal to 9.3 because of the barrier potential we are having for the diode. When the input voltage is less than 0.7 volts, again the diode will be in the off condition. The waveform will be like this. So during the negative half cycle, output voltage is equal to 0. This is how we are going to find out the output voltage as well as drawing the waveform for input and output voltage.